Murupaka, Srikakulam district. Students, let's explain now that lesson. What's the lesson? Principle of method of mixers and how to derive the resultant temperature of the mixer. That is, two samples we have to take. First of all, let us take 2 beakers of 100 grams and 200 grams of water. Here 100 grams and 200 grams of water we have taken. Take a thermometer and insert in the beaker. Observe the reading of the thermometer. We have to take the thermometer and inserting in the first sample, that is 100 grams water sample. Now its mercury level is increases and it will be 90 degrees centigrade. So this temperature increases up to 90 degrees centigrade. So the 100 grams of water is a sample. In this sample the temperature is 90 degrees centigrade. Now take another thermometer and insert in the second beaker. We have to inserting and we observe the mercury level is increasing now. So it is increasing up to 60 degrees centigrade. 60 degrees centigrade means this is the another sample. In this sample water is taken as 200 grams and its temperature is 60 degrees C. But the first sample is 90 degrees C centigrade sample, but it is 100 grams, and this is the 200 grams 60 degree sample. Both samples are hot waters, even though you have to mix the both samples in a big beaker, and then we find the method of mixer, principle of method of mixer, and we can find the resultant temperature of the mixer after mixing these both sample, 90 degree centigrade sample and 60 degree centigrade sample. Now observe the reading of the thermometer is 60 degree. Now we observe that 100 grams beaker temperature is 90 degrees centigrade, and 200 grams beaker temperature is 60 degrees centigrade. Now mix the two beakers of water in another big beaker and observe the thermometer reading in it. Now we have to take the big beaker. This is the big beaker we have taken. In this beaker we have to mix the both samples, that is say 90 degree centigrade sample and 60 degree centigrade sample. Both samples we have to mix in this beaker. If you mix the both samples in this mixer, in this beaker, and we have to inserting the thermometer and observe the temperature. What's the resultant temperature in this big beaker? You know, after mixing this both samples in this beaker, this water level in the big beaker is 300 grams, and now you have to insert thermometer in it. If you insert thermometer in it, what we have observed, we can both mixers are in thermal contact 90 degrees centigrade and 60 degrees centigrade. That means 100 grams water and 200 grams water, they should be in the thermal contact, they should attain the thermal equilibrium, and they show the resultant temperature. What's the resultant temperature? Now we can observe, yes, we can observe the resultant temperature is, wow, this resultant temperature is 70 degrees centigrade. Now this is the resultant temperature. How can you derive the generalized formula for this resultant temperature? That is our next concept. How can you derive the generalized formula resultant for the resultant temperature of this mixture? Now let's derive it. So what's the, let the initial temperature of the samples of mass M1 and M2 be T1 and T2. Let T1 is higher temperature and T2 is the lower temperature. You know, before this activity, T1 is the 90 degree centigrade and T2 is the 60 degree centigrade. That means T1 is the higher temperature and T2 is the lower temperature. Let T be the final temperature of the mixture, and it is lower than the temperature of the hotter sample but higher than the temperature of the colder sample. Here T means after mixing the both samples in the big beaker, we observed some temperature 70 degrees C. That is nothing but T. Now we have to generalize like that. T is the final temperature of the mixer. Now see, So the amount of heat lost by the hotter sample, how can you, what is the, which is the hotter sample? First sample is the hotter sample. In the hotter sample, the amount of heat lost by the hotter sample, how can you find? You know already, Q equal to ms delta T. Here Q means Q1, M means M1. M1 means, here we, in the example, in the activity we have taken 100 grams M1. S means specific heat of water, because in the both samples we have taken same specific heat material, that means water. That's why S is S, no S1 or no S2, but that means the specific heat is same for both samples. But the change in temperature, delta T means T1 minus T. Here T1 is the temperature of the first sample, T is the temperature of the mixer. That means T1 minus T is the difference in temperature, delta T. That means from this formula we can write Q1 equal to M1 S T1 minus T. Now the amount of heat gained by the cooler sample. What is the cooler sample? The second sample is the cooler sample. In the second sample, quantity of heat is Q2, mass is M2, S is same, specific heat of water, but the delta T is the higher temperature minus lower temperature. Higher temperature is the mixer temperature and lower temperature is the second sample temperature. That means T minus T2. From these two equations we can equating the both equation, because after mixing the both samples they should attain the thermal equilibrium. At thermal equilibrium since the heat lost by the hotter sample is equal to the heat gained by the cooler sample. Now assuming no loss of heat to surroundings. This is very important. Now at the stage of thermal equilibrium, Q1 equal to Q2. If you write you have to equating these two equations, that means which can be written as M1 S T1 minus T equal to M2 S T minus T2. Now we can simplify this equation. Which can be simplified? How can, here on the both side S is same quantity. That's why we have to cancel each other on both side. M1 T1 minus M1 T equal to M2 T minus M2 T2. Now we can write the equation for T. We can write the equation for T very simply. We can simplify the equation into T is T equal to M1 T1 plus M2 T2 by M1 plus M2. This is the resultant temperature from this equation. T equal to M1 T1 plus M2 T2 by M1 plus M2. So this is the equation for the resultant temperature of the mixer. Okay, students. Next one is, from this activity and derivation we can define the principle of method of mixer. What's the principle of method of mixer? Now we can define very easily from these activities and this derivation. What's the principle of method of mixers? Okay, this when two or more bodies at different temperatures are brought into thermal contact, so then the net heat lost by the hot bodies is equal to the net heat gained by the cold bodies until they attain thermal equilibrium, if heat is not lost by the any other process. This is very important here. Now from this principle we can write net heat lost by the hotter body equal to net heat gained by the cooler body. Okay, so this is nothing but this is known as principle of method of mixers. Okay, students, in this class we explained so the derivation of method of mixers and definition of principle of method of mixers. Okay, are you clear? This is very important so we can understand it. Okay, students, thank you for watching this video. If you like it, subscribe, like, share, friends.